Hello, my name is Sofia and I'm a Master in Sports Training. I am a collaborator of Faculty of Sport of University of Porto and I am also a swimming coach. In the current presentation, I will talk about the glide, its importance and relationship with other variables, and the evaluation process. Competitive swimmers should have two aims to improve their velocity and then to enhance performance: maximize the propulsive forces produced by the propelling segments, and minimize the hydrodynamic drag resisting forward motion. The efforts to minimize hydrodynamic drag should be carried out during all swimming phases. However, decreasing drag during the gliding phases should be a main concern for swimmers and coaches, since the underwater gliding plays a major role to the overall swimming performance. In gliding phases, the swimmer body undergoes a resistive acting force, known as passive drag, since it is not actively changing the orientation of their segments. So, the glide refers to phases in swimming during which the swimmer attempts to maintain the velocity without actions to propel the body. Glide phases occur during starts, namely during the underwater phase, and turns, and also within stroke cycles of breaststroke. During the glide phases of starts and turns, to help to minimize deceleration and drag coefficient, swimmers typically adopt a streamlined position, characterized by an elongated posture, by aligning their upper limbs with the lower limbs and torso, with arms extended forward, with hands pronated and with one hand on top of the other, and the feet together and plantar flexed. So, the glide is a critical skill for swimmers, as glide performance significantly influences overall swimming time and is a determinant race component. For example, elite swimmers spend about 3.7 seconds underwater during the start, where the time spent in a glide posture between the head entering the water and the initiation of the first undulatory kick is about 1 second. So, glide performance is determined by the initial velocity from the block start or the wall push-off and the ability of a swimmer to minimize deceleration, also known as glide efficiency. Glide efficiency can be defined as the ability of a gliding body to maintain its velocity through time and to minimize deceleration at each corresponding velocity. The lower the deceleration at each corresponding velocity, higher is the glide efficiency. Although increasing initial velocity of a glide is one of the ways to optimize the glide performance, improved glide efficiency can be beneficial because an advantage is gained without increasing the metabolic cost. So, swimmers' hydrodynamic profile can be assessed with different validated techniques, as the velocity perturbation method, the measuring active drag system, or the swimmer's passive drag assessment, with the swimmer towing in water without segmental actions. However, these procedures are expensive and require highly complex techniques to be used on a daily basis. Thus, cheaper and easier testing procedures for this assessment, like the prone gliding test, is used to assess the swimmer's hydrodynamic performance. In this test, swimmers are asked to push off the wall at a given immersion level and to glide in the streamlined position for the maximal horizontal distance that they are able to travel without limb action. The test ends when swimmers achieve the water surface and/or started any limbs actions. It measures the maximal horizontal distance traveled by the swimmer from the wall to the feet, and it is considered that higher gliding distances represent a submission to lower drag force. Factors that affect glide efficiency include posture and alignment, and anthropometric and morphological characteristics of the body, by influencing fluid flow movement and velocity. According to the notions previously presented about the passive drag and the way he affects the body, modifying posture during gliding may affect the magnitude of body curvatures, frontal surface area, and the associated fluid flow characteristics. For example, it is known that gliding in a position with the arms fully extended at the front in prone and dorsal positions presented lower drag coefficient values than the body position with the arms aside the trunk, and that gliding in a lateral position, also with the arms extended, presented lower drag coefficient values. Regarding the anthropometric and morphological characteristics, the body mass, height, and trunk diameters, as biacromial and biiliac breadth and streamlined chest circumference and breadth, are strongly correlated with passive drag. In fact, the streamlined position adopted during passive gliding becomes increasingly important to minimize the drag. The reduction of the swimmer's frontal area and the non-uniformity of the body shape are key factors for performance, particularly during the start and the turns. Indeed, when the fluid hits impact points along the swimmer's body, such as the head, shoulders, and glutes, the local pressure increases and the fluid speed decreases, resulting in the generation of vortexes and an increase in turbulence and pressure drag. So, all these hydrodynamic principles should be used to inform technical glide strategies for coaches and swimmers with the goal of improving glide efficiency. And thank you all for your attention.